everyone. Welcome to the demonstration of Derma product recommendation rack system. This system intelligently recommends skincare and hair care based products on the user preferences while also handling the general skincare queries. So I'll just begin with the overview of the tech stack and the architecture involved. Uh, so for the vector database, I utilize the VV8 Vector DB. So it stood out for me because of its hybrid search capabilities, which is both semantic and keyword based search. This capability significantly improves the recommendation accuracy by ensuring return products closely match with the user constraints, along with the simplistic similarity search. And additionally, it also provides excellent scalability and structured metadata querying. And for the embedding model, I utilize the sentence transformer BAAI model as on benchmarks like MeetEB, it performs better over the OpenAI embeddings, and it is a locally deployed model, so there is no API cost involved, making it an ideal choice. And for the base LLM, I use the GPT-4o model as it generates highly coherent and context sensitive responses without the need for extensive any kind of fine tuning or infrastructure overhead. And as this is a very simplistic workflow, there are not much chains involved. There is only two kind of retrievals, either based on the web search or on the based of the VVA database. So without complicating it much, I utilize the LangChain framework as it helps in the querying and orchestration logic while providing a built-in chain which are ideal for dynamically routing queries between our semantic database and the external web searches. Now coming to the technical architecture part. Uh, so during the first step of the data ingestion and storage, I loaded and processed the XLSX file provided and ensuring the only relevant columns are retained and the retained columns are descripted into the dense vector embeddings and which are stored later along with the metadata into the VVA database. And there is also a need of maintaining a structured schema in VVA to allow hybrid querying process. And coming to the query processing part, so every query undergoes the intent classification, which is distinguished based on the LLM, which is done by the LLM. Every query undergoes intent classification based on product queries or general queries. So prompt engineering is utilized, and if the query comes out to be a product based query, then further additional filters are added before uh, forwarding it forward. There are additional filters added, and the RAG system generates a retrieval where it fetches the relevant information based on the query type. If it was a product based query, then it directs it towards the VVA database where it will do the querying based on keyword based filtering and the semantic search. And if it's just a general query, then it directs it towards our Tabeli API, which does the web search. Now coming to the demonstration part, I'll just show you a few examples. Uh, so let us take a look at this example. So here, there along with the basic semantic search, there would be a need of keyword based search, as there is a need for niacinamide to be involved, and there needs to be metadata filtering for products which are less than 500 rupees only. So the response it generated, you can see the two moisturizers it recommended, both are below 500 rupees and both contain niacinamide as an ingredient. So it performed quite well in this. Now I'll just do a real time presentation, and I'll just show on Steamlit platform. So let us initially take a very basic example for the skin emulsion. Let us see what it generates. So as it is a very basic example, so here only the semantic search would be involved. There are no additional constraints, and our embeddings via our BAI find products closely related to the semantically most nearest neighbor, and it will generate the response. As we can see, it gave us a recommendation of these four emulsions. So there is also additional information provided along with that. And let us complicate the query a bit, and let us take this query. uh, so here the query is, I'm traveling to a humid city next week, can you recommend some lightweight products with skincare routine suitable for the climate? So we gave it a context along with the product recommendation. There needs to be a context involved for which it will be querying. And so here there would be a need of GPT-4's ability to understand the context, that it is a humid climate and lightweight preferences, and the embedding selects the products relevant to humid and lightweight skincare. So you could notice that it recommended on the basis of humid climate, and there are some versatile options it recommended for the humid climate. uh, so it could be seen that along with the recommendation, it also provided a simple routine for applying it along with the name of the products that it recommended, how to and where to use. So now let me take an example of a query where there would be a need of a web-based search. So let us take this query. I have a sensitive skin. What ingredients should I use avoid in the skincare product? So here there would be a need of web-based search. So here instead of retrieving the data from our VVA database, it would intelligently recall from the web. So as we can see, it generated the whole ingredient list which the person should avoid with sensitive skin. It is a very vast response that it gave. Now let us demonstrate its conversational history capability. As I have utilized the conversational history in the backend part of it. So let us take this example. Based on the conversation history, can you suggest a routine for my skin type? So let us see if it is able to retrieve the previous conversation that we had according to that. So as you can see, it was able to find out that I need the recommendation for a sensitive skin as I prompted it earlier, and it also remembers that I need it for the humid conditions. So as I am going to a trip to a humid city, so it recommended the moisturizer, the sunscreen, and the entire morning and the night routine according to that only. It also gave some additional tips. So this was a good response it gave. Now let us take one more example where there is some sort of constraints involved, and it could not directly be searched on the basis of semantic nature. So this is example where it is asking to recommend a serum which is under 2000 rupees and contains a hyaluronic acid. So as you can see, it sounded great. It said and it recommended a serum which is under 2000 rupees, which satisfies a constraint, and it also gave the key ingredients and why is it suitable. So this was the basic like demonstration of its capabilities. Now while doing this, I faced some challenges, like when I was trying to do the model selection. Initially I attempted for the embedding part, I attempted the OpenAI embeddings, but I faced some API accessibility issues, so I instead switched to the BAI sentence transformers. And while doing the, especially during the hybrid query optimization, I faced challenges in turning semantic similarity along with like keyword based search. So that also I did some careful balancing there. And while implementing the conversational context for the conversational memory, there also it was a challenging task, and I implemented it for the accurate context recall needed for iterative improvements in prompt engineering. So, and for the further improvements, I would say we could do enhance the system by doing some re-ranking where there would be a dedicated re-ranking model involved to refine and prioritize retrieve results. And we could expand our data set. We could expand our data set, and uh, more parameters could be introduced which will refine the results more. And there could be user profiles or personalization that could be created, and we could store preference and skin conditions to significantly enhance personalization based on a user profile. And I also mailed you another multimodal model. We could integrate this product recommendation system with that, and it could generate a very good use case and could help us retaining the users, and it could be a very good use case. So yeah, thank you so much. So this carefully chosen tech stack of VV8 GPT-4o, sentence transformers, LangChain, and the Tavily API. So I try to ensure our system is scalable, accurate, and context rich while being highly responsive. So yeah, thank you so much for watching this demonstration. I'll be happy to answer any questions via mail if you have. Thank you so much.